All right, what questions you want to talk about? Homework questions from last night, anything?
19.
19? And that's the thing, just shout numbers out. And basically,
21.
we'll stop once we're done shouting numbers out. All right, so 19, let me kind of zoom in on this so that the camera see it. Find the measure of each angle, okay? What we have to realize, and I don't know if we talked about this yesterday, we need to make a relationship, right? Hopefully we recognize that the two angles here that we're going to be dealing with, the two minor angles or smaller angles, are the 10x plus 2 and the 10x plus 8. So we're looking at, color them here. Let's do this. We're looking at that angle there. And that angle there, right? Those are the two that are adjacent. We're using the angle addition postulate. So those are the two that we're going to add together, okay? So there's the relationship. Those two are going to add together, 10x plus 8 plus then 10x plus 2. All right. Now if we're going to add those together, we got to know what the total is. And they don't tell us a total explicitly. They kind of imply what the value is. They hide it with notation.
Oh, it's 90 degrees.
It's 90 degrees. So we got that box in there, and that tells us that that angle is 90 degrees. So those two smaller angles, the yellow one and the green one, should add up to 90. There's our relationship. We got, what, 20 x's. I'm going to subtract the 8 and the 2 from 90 at the same time, so it gives me 80. So x then should be, what, 4? So then we're going to go, 10x plus 8 is 48. 10x plus 2 is 42. And those do combine to give me that 90 then. And here's what I'm talking about. Here's what I want to make sure we understand. I have seen people ask me questions about this, and they'll say, well, I know that 10x plus 2 is equal to 45, and I know 10x plus 8 is equal to 45. Because it looks like it, right? It looks like they're taking that ray. Just ignore anything, ignore all these numbers and stuff. Does that ray look like it's cutting the angle in half?
No.
Huh?
Nope.
No? Okay. Does anybody think it might look like it's cutting in half? You're going to see at times this year where they give you an angle and it looks exactly like they're cutting it in half.
No.
But you can't say that until you know they're cutting it in half. Okay? So we don't know. There's nothing in here saying that those are the same. Okay?
Closely.
Huh?
Closely.
You look close. You zoom in a little bit closer, and you might be able to tell that they're not the same. But I do get that. I get a lot of people say 10x plus 8 equals 10x plus 2. Okay? Or I get 10x plus 8 equals 45 because they think they're cutting in half. Make sure that you're only using the relationships that they're specifying that they're providing you. I think that's it for that question. Make sure you pay attention down here. Type an integer or a fraction. Okay, so they're basically telling you don't use decimals, right? Okay, if you would have found like 4.5, they want you to write that in as 9 over 2. Okay? Okay.
Can we do 20?
Yep. Okay. You want to do 22 or?
I don't understand how to find x. Like, I went through my notes and everything yesterday, and I still couldn't like figure out how to find x.
Oh, it's right there. All right, so this is a good question, Go, because it is a little confusing. Because what we started, and this is the thing that I want you guys to kind of fight against, because you're gonna see this in your homework tonight as well. You're going to get in a mode of wanting to do the same thing from question to question to question. So you see 4, 5, 6 questions that are strictly angle addition, right? And then you get to the 7th question and you think, because of what I've already done in the assignment, I should do angle addition. So initially people read this and say, okay, I've got 3 angles here. I've got this one here, I've got that one there, and I've got that one there, right? And those relate to these values over here. So most people, without paying much attention to what's going on, because they're in that robotic mode of what they've already done 6 or 7 times, they say, well, I'm going to take 4x minus 2 plus 6x plus 12 plus 2x plus 14, because those are these 3 angles here, and I'm going to set them equal to the whole thing, right? Okay. Somebody asked this question yesterday in one of the classes, and that's kind of what we initially started doing. We neglected the the picture and we just saw all those expressions and start adding together, and we got to the point where, okay, now what's the total? And I'm going to zoom out. Maybe. We ask what is the total, but nowhere in the question, nowhere in the description does it give me a total expression or a total quantity or anything like that. Does that make sense? So that told me instantly, we're probably doing something wrong. Let's look at it a different way. And then we looked at the picture and said, oh, what's the picture telling us? What are these markings in the picture telling us about those angles? They're congruent. They're the same. Okay? So that tells us the measurements are equal. So we're going to say that AOB, that angle there, and angle COD, this bottom one, those two angles are equal in regards to their measurement. So we're going to set up an equation that says 4x minus 2, which again is the expression for that angle, is then the same as or is equal to 2x plus 14. Go through and solve, so 2x equals 16, x is 8. Now that x is 8, I'm assuming that the rest of the question, is there more parts to this? Yes, there's 3 parts remaining. I'm assuming the next thing that they ask you is, can you find the measurement of each one of these? So if I've got 8, I can go in here, okay, 4 times 8 is 32, minus 2 is 30. Okay, 6 times 8 is 48, plus 12, what's that, 60? And then, we should know this already, but let's just do the math. 2 times 8 is 16, plus 14 is 30, which is verification that we've done things right because we said originally that they were equal. Okay, so we get an angle here that's 30, 60, and 30. We could add those together, say angle AOD. I don't know if it asked this. The measure of angle AOD could be 120. Does that make sense? On like a test question, a lot of times I like to take questions that they've created and that you've seen 1 or 2 or 3 times in class, and I like to rewrite them and just basically maybe change it a little bit. So what I would maybe do in this question is provide all that for you, but then I don't care about what x is. I don't care about what AOB and BOC and COD are. My question is going to say, find the measure of angle AOD. Find that total angle that we said was 120. Because if you can show me that you got that to be 120, does it show me that you were able to find x? Does it show me that you're able to find angle AOB, angle BOC, and angle COD, right? Okay. So it shows me you can do all those things. But in a homework question, it's nice that they do tier it and stagger it so you know, okay, I've gotten, maybe I'm getting the second part wrong, but the first part right, so I know everything up to that second part I've done correctly. But on test or quiz, I might change it a little bit. Always, always, always trying to look for relationships and understand from question to question, the relationships might not always be the same pattern. We just have to make sure we're paying attention. Something you're also going to see in the notation, this is what I don't know if I've said this before, but I kind of hate math in this regard, that the notation can change from author to author, from textbook to textbook, subject to subject. Sometimes it even changes. One thing you're going to see, sometimes they'll put just an arc in these angles to show that they're congruent. So, just like they have here. Sometimes they put that extra mark in there like that, like we do a segment. Okay, I like that format. That's what I'm going to use the most often. But you'll also see something like this from time to time. If I want to show those 2 angles congruent, we'll do this. Maybe 2 arcs. Okay, maybe I've got those 2 blue angles are congruent, and maybe I want that red one and that red one to be congruent, but still be different than the blue ones. So just like we put hash marks in those lines, 1 hash mark or 2 hash marks or 3, we can do the same thing with those arcs, and the number of arcs that you have in an angle should be then compared to any other angle that has the same amount of marks. Okay. It's always a learning curve initially, and in really any math course, to learn how things are being expressed, how they use notation to say different things. But hopefully the sooner we pick up on those, the easier questions like this might be, and we can recognize that a lot quicker. Any others?
Number 9.
9? Okay. All right, so when we click on, I'm going to just click on these, and you see that everybody, regardless of the time that you got, it's always a full hour, right?
Yeah.
Okay. this question can be a lot more complex when we say, what's the time, or what's the angle between the minute hand and the hour hand if it's like 8:22, okay? Because if it's 8:22, isn't the hour hand, hasn't it moved a little bit towards 9 already? Does that make sense? Okay, so we'd have to incorporate that idea inside of finding that measurement. We will do something like that if you end up taking trigonometry. That's one of the questions when we start applying what we learn in trigonometry to real life situations. We do questions like that, but it becomes pretty involved. What I want you guys to think about, we're just going to put this on the axes, but center at 0, 0, but that's my clock, right? Where I got that blue dot up there, that would be 12 o'clock, correct? Okay. If we have, so that's 12 o'clock, let me write that up here, 12 o'clock, that's terrible.
Like 12.
I gotta open this thing again. There we go. Alright. So we've got 12 o'clock up here. We've got 3 o'clock would be down here, correct? 1 and 2. What's important to understand for this problem is that the amount of minutes between 1 o'clock and 2 o'clock, is that different or the same as the amount of minutes between 2 o'clock and 3 o'clock? In 1 hour, does the number of minutes ever change? No, it's constant. It's always the same, right? So if I've got, let's just to focus on our minute hand here. If my minute hand is there, okay, and I want to talk about it moving to 1 o'clock. We'll get there. Okay. So we've got our minute hand here at, come on, 12 o'clock. Okay. I want to think about that angle that is traced out when that minute hand goes to 1 o'clock. Okay? Would that angle there be the same or different than the angle from 1 o'clock to 2 o'clock when that's traced out?
No.
What should they be? Should they be different or would they be the same?
They would be the same.
They would be the same, right? Because the amount of minutes between 12 and 1 is the same as the amount of minutes between 1 and 2, right? Okay? And the same thing from 2 to 3, and then 3 to 4, 4 to 5, 5 to 6, and so forth all the way around. Okay? So, how many degrees are there in that first quadrant? There's 90 degrees, right? Because the y-axis and the x-axis are perpendicular to one another. So that's a 90-degree angle. We have 3 individual angles that are being added together, right? 1, 2, and 3, correct? Okay. Their total should be equal to 90, correct?
Yep.
But they're all the same.
Yep.
So what is 1?
30.
30 degrees. So that's 30 degrees. Okay? So basically your clock is going to be broken up into 12 slices that are all of a circle, 12 slices, we call them sectors, that have a central angle of 30 degrees. So now if I have it, if the question is it's 8 o'clock, okay? So if it's 8 o'clock, your minute hand is pointing there, and your hour hand would be down here, right? Okay. So you're going to have, you got your 11 o'clock, you got your 10 o'clock, you got your 9 o'clock, right? So how many degrees are there?
120.
Okay. All right.
90.
90 right there, what I've drawn out. Okay. But then Cameron is saying, plus I got that additional from 9 o'clock to 8 o'clock, another 30. So then this angle here that we're really interested in, that's being created by the hour hand and the minute hand, is 120 degrees. All right. But like I said, what happens with that question is now they say, okay, what is it when it's like 8:15. Well, if it's 8:15, isn't this hand here going to be pointing there? But now this one, instead of pointing right at 8, it has moved a little bit, right? It's moved a quarter of the way to 9, right? So there's a larger angle than 30 plus 30 plus 30 plus 30 plus 30 or whatever, how many 30s I got to put in there. I got to add basically a quarter of another 30. And it can be a little bit problematic to think about a lot of kind of stuff, okay? So the question can get a lot harder, but what you guys will see is 8 o'clock, 9 o'clock, 10 o'clock, 7 o'clock, that kind of stuff. They might get to half-hour things, okay? So if it's a half hour, how far is the minute hand moved to, or sorry, the hour hand moved to the next hour? So if I say it's, let's say that's my hour hand. Let's say it's 12:30. Is that what it looks like when it's 12:30?
No.
That would be halfway.
No, it's halfway, right?
Done.
Okay. So this was 90 here, right? Okay. Let me draw in. So you know that was 90. Okay. There's an additional 30, correct? There's an additional 30, correct? So 90, 120, 150. But now how much is this angle there? 15, okay? So you got 90 plus 30 plus 30 plus 15, and that would give you your total angle there, okay? When you talk, and this is just getting into a little trig that we don't really need to know, but when you talk about like the decimal portion of an angle, a lot of times we talk about it as the decimal, but we can also talk about it as portions of minutes and seconds. Okay. Have you guys ever seen, like, if you go to Google Maps? Let's see here. I don't have Google Earth on here. Will it give me, you guys know if it'll give me more map? There we go. All right, you see down here where it gives me like 40.795519 and negative 84.161160. Okay, those are your locations. I'm having trouble walking. Those are your locations via like longitude and latitude, right? Okay. They're showing you as decimals, but sometimes if you were to get into like Google Earth, they're going to show you, they'll put like 40 to put the degree symbol. And then whatever 79 is divided by 60, they'll put like a hash mark after that for minutes. And then the next decimal they'll put quotation marks for what we call seconds. And it's a better way of identifying degrees, okay, and the fractional part of degrees. So, and that's something we talk about in a trig class. So that question will forever change as you go through other courses. You'll keep seeing it, but it'll get more and more and more difficult. And you can talk about those ideas in a little bit deeper detail. Anything else you guys want to talk about? Yeah, go ahead.
26.
26. Is that the one with like the different colored lines? Like purple lines? No?
It's the purple one.
Okay. Okay. So we've got the situation here where these two segments, when we see this notation, these two segments are doing what to one another? When I have that and that, what does that tell me about distance AD and distance DC? Okay, the shapes are congruent, distances are equal, all that kind of stuff, right? And what about The green ones, what do you know about those two? They're congruent. Now is a yellow one the same as a green one? No, they're different, okay? But what this tells us, because AC is getting cut in half, is that EB is a segment bisector of AC. And likewise, AC is cutting EB in half, right? So AC is a segment bisector of EB. So that's just the way maybe we would talk about it and use those particular terms. But in order to solve for Y here, think about the parts that they give you. And this is what I like to do, is I like to look at my picture. Maybe I got to redraw it on some scratch paper or something like that. But I like to highlight the parts that they gave me. I think it makes it a little bit easier to recognize the relationship. So I got AD, that's 17, right? And they also give me AC, which is that distance, okay? What a lot of people want to do is they want to say 17 is equal to 5y minus 56, because those are the two things they give you, right? But if I look at those visually, is the red segment the same as the blue segment? No, they're not the same. They're drastically different. So I know, in fact, that 17 is not equal to 5y minus 56. But is there a way that I can manipulate one of these so that they become equal? Okay?
You multiply 17 by 2.
Right. This here, this distance here, is the exact same as that one, right? So if I double that one, okay, I'll try to get too fancy, let's double that one. Okay, now the red segment and the blue segment are the same thing, right? So I double the 17, should give me 34 equals 5y minus 56. Add 56 to both sides, so it's going to be 90 is equal to 5y. Y then has to be 18. Plug in my 18, and then it's going to ask you other parts. I think they ask you to find AC by itself, so just plug that in, evaluate it. And also ask you to find, I think AC total. Oh, yeah, no, AC and DC are the things. Does that help?
Yeah.
One thing that you got to pay attention to, and someone in the last class wasn't doing this, so make sure you're paying attention. They'll give you a lot of information right there, okay? And it's really useful information. I don't know how many times a year somebody will come up to me and they're like, I'm doing everything right. I'm typing in, I'm doing all the work, and I'm getting 19.5 back. And I tell them right away, I haven't done any of the math, but I know for certain that 19.5 is not the answer. And I'll show them to look at this, and what it will say is type an integer. 19.5 is not an integer, right? Okay. So if I do the work and I get a number that doesn't mimic the type of number they're looking for, that tells me the math that I've done is probably wrong. All right? Because what have they done? They've already done the problem, right? They already know the answer. So they're telling you what kind of numbers those answers are showing up as. So pay attention to that kind of stuff. If it says type as an integer or a decimal, okay, and I get a fraction back, you have to convert that fraction to a decimal. Or likewise, maybe you're a person that doesn't like fractions, so you do everything with decimals, and it says type a fraction in. You type your decimal, it's going to be wrong, right? So if I get 4.5 back, I have to convert that to 9/2 so that I get the right answer. Does that make sense to everybody? All right, so pay attention to those helpful hints here. They'll go a long way and eliminate some frustration for you as you progress through the course. You guys got anything else you want to talk about? Any other problems? Okay.
27.
27? Okay. Let me cut this one out and we'll go to a different. All right, so looking at this, the idea, and I like you guys, obviously you can't do this because you don't maybe have a smart notebook or whatever, but I want you kind of, maybe you can piece this together and visualize this in your mind as you're doing a problem like this on your own. I'm going to highlight or overlap a segment that is exactly the same length as 5x minus 2 and one that is exactly the same length as 4x plus 5. Okay? What we're saying here is if I want to go from G to K, okay, and that's what the problem said. You want to be able to find what the length g to k is. And they're telling us in the problem that g to k, and this one was 35. Okay? So obviously if I just start adding those quantities up, those expressions, I'm going to get something that is not 35. Okay? If I put these things into n's, let me change the color here real quick for this one. So if I take that red one, okay, which is starting here at h, so let's just come down here and slide it over so it starts at g. It's still the same length, it's still 5x minus 2. Would you guys agree with that? No matter where I put it, it's still 5x minus 2. Okay? Now if I add to it this black one, and adding to it means that we're going to go end to end, right? Okay? Has that red and black one started at g, but has it passed over k?
Yeah.
Alright, so if I wrote down what that expression would look like, that expression right now would be 5x minus 2 plus the black segment, which is 4x plus 5. Okay? And we know that that is longer than gk, so I'm not going to set it equal to anything yet. Okay? So we would, if we walked from here all the way down the red, all the way to the black, we'd be right here. How far back do I need to backtrack to get to k then?
X.
I need to backtrack x. Okay? And the reason for that is that x here, let's make that blue, maybe. Okay, that segment there shows up right there in the 5 or the 4x plus 5, right? It's also showing up in the 5x minus 2. So when I add those two things together, I've added this amount, I've added that distance, that overlap of h and j, I've added it one too many times. Okay? So I need to remove it. Okay? So removing is what operation? Subtraction. Okay? So I need to remove that. So I walked all the way to the end of the black one, but now I come back that blue distance. And that then should equal what GK was, and they told us it was 35. Okay? The idea is that there's overlap. Whenever you have overlap, you want to make sure, and you just start adding the expressions together, that overlap has been added in multiple times. So you need to eliminate it so it only gets counted in once. Okay? So if and I'm not specifying which one I'm eliminating it from, but let's just say I eliminated it from 4x plus 5. That means 4x plus 5 really would have shrunk down to being just that black segment there. And then I have that red segment. Can we all visualize it? If I put the black one end to end with the red one, it would get me from G to K. All right. So then we just go through just like any other problems. I got 9x to be 8x. Move over the 3 there, so it would be 32. So 8x equals 32. So x would be 4 in that particular problem. Okay? And then it's going to ask you, can you go back and find all 3 segment lengths and that kind of stuff. All right. Good question. You will see something like that soon. Okay? What I want you guys to do, run out of time here. What I want you